welcome to this tutorial on how to use a microphone module. Now, like most sensors, microphones require power, and they get their power by connecting two of their pins to ground and plus a certain voltage, in our case 5 volts. So they're going to have two pins labeled generally G and plus, and what we do is connect G to ground and plus to 5 volts. In our case, G is one of the G and D pins here or up there, and 5 volts is the 5 volt pin. Now the other two pins are A0 and D0. All modules have the analog pin, A0. Some of them have a digital pin. So I'm only going to cover the analog pin. Now, once you have connected it, one thing should happen. Two lights should come on. If two lights don't come on, you need to turn this knob until both lights come on. When both lights come on, your microphone is working and it will be giving a value on A0. So this pin here, if we connect it to any of our analog pins, we'll connect it to A0, we'll be able to read a value off of it between 0 and 1024. So, unlike perhaps the ultrasonic sensor, the heat sensor, this is not a precise value. We're looking at something rather raw, but it's a value that when there is noise around will increase. So if our reading is say 200, we can turn this knob here and increase it to 300, 400, 500. So it's not an objective reading in that sense, but if the reading is 200 and I make a noise, it'll jump to 205 or something like that. So this microphone, we can easily use it to detect noise. And this is what our circuit that we build today is going to be about. In future circuits, we're going to refine this and get into circuits that react to sound and music. Alright, that's the theory. Let's build it.
Alright, so as usual, we're going to start by powering up this breadboard. But this time we're going to go for powering up the far side first. So 5 volts into the red rail and G and D into the blue rail. Now, for our noise detection, we'll be using this microphone right here. It's very similar to other models you can buy on DIY websites. Essentially, all of them have an analog pin, ground, and 5 volt or plus terminal. It can also go into 3.3 volts. If everything is working, 2 LEDs should come on. Now, if only one LED comes on, then you can turn this variable resistor, and hopefully the second one will come on, getting you sufficient power to run this thing. Now, we are going to essentially get this A0 pin to go into the A0 pin on the Arduino, and that's what we're going to use to read our microphone values. So, to get us started, we'll just get A0 onto maybe one of the rows. It'll be in row 6. So on our microphone, next up after the A0 is the ground. So we'll put something like that into adjacent to it. And I use these breadboard wires instead of jumpers only because they look neater in videos, but otherwise I would not be adverse to using jumpers here. Now I think if we plug our microphone in right here with the A0, it should be ready to go, and both lights are on, and it is ready to go. You can't see it from that angle, but trust me. Now, as some indication that the microphone has been turned on, we're going to grab an LED and put it perhaps into pin 11. So, oops, between pin 11 and G and D, so 11 is there and G and D is there.
Alright, so here's some pre-written code as usual. Let's have a look. Firstly, we've got a mic pin, which is pin A0, so that's the yellow cable going from the microphone into pin A0. Siren pin, in our case it's the green LED, hooked into pin 11 on the Arduino. And these two are quite interesting. Essentially,
we're going to have a microphone that's giving us 1,000 readings a second, and we're going to store consecutive readings and compare them. So if the second is bigger than the first, then we can trigger off our mic. And these 2 bits of code confirm what I said in the first 2 lines. Now that says serial begin. We're initializing our serial terminal, which is right here, which will enable us to display values of Arduino pins on our computer. And here's the rest of the code. It essentially says mic value 1 is a reading on our analog pin, on our mic pin, and mic value 2 is the next reading 1,000th of a second later. Bam, right here. So this bit of code should compile, and we'll be able to upload it and check out what readings our mic is giving us. And it's uploaded. So our mic is giving us very low readings, but if I were to come closer to it and speak, it would increase only slightly. Now, its optimal range is actually above 100 and under 1,000. So if I turn this, I'll hopefully be able to get it up. Alright. It doesn't matter really what values are on the screen as long as they're above 100. They serve our purpose. And the idea is, as you can see, when I clap loudly, the numbers go up. So everything's functioning. So now we can write a little if function that says that, oh, if our second reading is bigger than our first, we can trip off the alarm. So we can write if mic value 2 minus mic value 1. We're going to use a bigger than sign. So if that's number that's bigger than 1, so if it's 2 or 3 or 4 or more, then we can set off the alarm. So it's called siren pin high. And leave it on for a second. Maybe 2. And after that, we're going to turn it off. Okay, so time to test this out. Open bracket, close bracket, we need to close out that if, and upload. Ha! There you go. It works. Now, before I sign off here, just to let you know, you can change the sensitivity of the microphone. If I made the 0, it would be even more sensitive. If I made it 2, it would be less sensitive. Another useful thing you can do is perhaps enable it to detect when there's a sudden drop in noise level, which is also maybe an event of sorts. To do that, you can create an OR function. So you could say if mic value 2 minus mic value 1 is bigger than 1, or mic value 1 minus mic value 2 is bigger than 1, which can be created using 2 straight lines. I think, yeah, 2 of these. And it's essentially the same, except you turn these around. So you'll put 1 minus 2. So this should also work, and it should make it a little bit more sensitive. Oops, mic value. That was too. Correction. Radio. Signing off. Hope you enjoyed this.